Good evening. We're testing the microphones a little bit here. Welcome to all first-time visitors to the college, and welcome everyone to a somewhat unusual form of the old custom of Friday night lecture. Tonight, rather than presenting one speaker, we offer 9. But we hope that they will constitute one conversation, and that the conversation will exemplify what the college seeks to do in all of its work, namely bring people face to face with what it means to learn. That means the discussants will not be chiefly seeking to act as pitchers full of something called knowledge, which is to be poured out into the ears of listeners, but as partners in a common search for things whose character they are not themselves entirely sure of. I should add that at the end of the conversation among the participants, among the panelists, we'll all pause for coffee, tea, water, and/or cookies in the hallway, and that after 10 or 15 minutes, those of us who wish, and certainly the panel, will reconvene in here and have what is known as the question period. Usually that would happen down the hall in the junior common room, but it seems simpler to stay here at this table. Answers are not guaranteed in the question period, but are certainly attempted. As is our custom, we begin from a common text, in this case a short speech given by physicist Niels Bohr in 1932 at a meeting of scientists concerned with what he calls the beneficial effects of light in the cure of diseases. As is also our custom, we do not seek a common understanding of the text as a final end, but as a means. A number of you will have read the piece which we've made available, but especially for those who may not have had time or opportunity to do so, it seemed good to say a few words about it before beginning the conversation. Like many texts we read, it is not perfectly clear and simple, and it assumes some familiarity in its audience with the tradition from which it arises. But it occurs to me that we should also make sure that the other microphones are working and practice using them. Maybe each of us could introduce him or herself. We could start with Mr. Poppele, and it will give us practice passing the microphones around, which we'll need to do in the conversation. You could just hold it that way, yeah. And then I will resume my introductory remarks.
So, I am Mr. Poppele.
He's from the Santa Fe campus.
I am from the Santa Fe campus. I am still at the Santa Fe campus. I'm an alumnus of the college, and my background, my academic background after St. John's is in environmental engineering, applied microbiology. So my questions, or my interest in these questions, comes more from the side of biology, but in a curious way in its application rather than its direct study.
I'm Mr. Bleichmar, Guillermo Bleichmar, and I'm at Santa Fe as well. And my background is in literature, so my interest in these questions is to understand them as a start.
My name is Chester Burke, and I'm a tutor in Annapolis, Maryland, and I'd like to thank the Santa Fe community for inviting all of us out here. This extraordinary, this mini conference has been called. It's going to be a lot of fun this weekend, so thank you.
I'm Brendon Lasell. I'm a tutor in Annapolis.
I'm Cary, Stickney. I graduated from the Annapolis campus, but have been a tutor here for longer than I am able to remember.
Bill Donahue, and I'm Director of Laboratories here on the Santa Fe campus. But like Mr. Stickney, also an alum of the Annapolis campus.
I'm Janet Dougherty. I'm a tutor here in Santa Fe.
I'm John Verdi. I'm a tutor from Annapolis, but I taught here for 10 years.
Recco. I'm a tutor in Annapolis.
Well, back to the quick kind of introduction. I'm not worried about looking like a pitcher full of knowledge in the following remarks, and I notify my colleagues in advance that they are invited to revise or correct any of the things I am about to say. I want to give a brief précis or summary of a couple of the things Bohr assumes are known to his audience but may not be known to all of us. First, light as a wave and the interference patterns of waves. If you drop a pebble in a perfectly still pond, the water surface beneath the pebble will go down in a kind of miniature crater shape before letting the pebble drop to the bottom. But then the water will rise in a small bulge because the return of equilibrium resembles the recoil of a plucked string. The parts of the water are pushed or pulled back to where they were, but the push or pull has given them some momentum, and they do not immediately stop when they reach their starting point, but go past it in the opposite direction from their first displacement downwards. Like the vibrating string, the water will go up and down for a little while before settling back to rest. But each piece of water is connected to its neighbors, and so the disturbance will propagate through the pond in expanding circles, one after another, until the original crater and bulge have become flat water again. We mostly only notice the first circle because it is the biggest, that is to say the tallest, and the water does not take long at all to return to rest. A wave is thus not a material thing that travels the length of the pond, but a pattern of up and down passed along in neighboring pieces of water. The particular water that goes up and down where the pebble fell is not the water that laps the far side of the pond a few seconds later. If you drop a pebble at one end of the pond, and I drop one of the same size at the other, then when your wave meets my wave in the middle, the patterns will pass through each other and each continue on its own way. But at the places they cross, they will change the shape of the water differently for a few moments, first reinforcing one another and then canceling one another, then reinforcing again before resuming their normal shapes. That is, the leading edge of each wave, which we are imagining as a down then up pattern spreading outward through the water, encounters the leading edge of the other, and thus the same piece of water is pulled down at the same time from two different sides, and so is pulled deeper. A moment later, the down part of my wave is acting on the same water that is also responding to the up part of your wave. And if our pebbles were really the same size and dropped from the same height, there will be a spot of flat water where our two waves momentarily cancel each other's visible patterns out before proceeding to the next appearance in which the up part of each works on the same piece of water for a moment, and there is a doubly high bulge. Now suppose that light moves as an unending series of waves at regular intervals through some sort of medium analogous to water. The sort of interference just described can be duplicated with two light sources or one light source passing through two separate openings and falling on the same surface, as Thomas Young showed early in the 19th century. If light is a wave-like disturbance propagated through a medium resembling water, then there should be situations in which the meeting of two lights results in regions of darkness, just as the two pebble waves made flat water for a moment where they met. And there are indeed such situations. Bohr says, quote, "These interference patterns offer so thorough a test of the wave picture of light propagation that this picture cannot be considered as a hypothesis in the usual sense of this word, but may rather be regarded as the adequate account of the phenomena observed." End of quote. Yet, as he says a moment later, this seemingly sufficient understanding does not fit other aspects of light more recently discovered. The photoelectric effect, in which an electric current can be generated by shining light on certain metals, shows light behaving like a particle, a kind of cannonball arriving at the metal surface and dislodging a bit of electricity, one piece at a time, so that it makes sense to speak of the energy in a photon, a single particle of a particular type of light, as a fixed quantity. But the quantity of this lump of energy can be calculated by referring to the frequency, that is, the rapidity of the up-then-down motion of the wave belonging to the particular light, say infrared or ultraviolet, that is in question. We seem unable to discard either version of what light is. Waves do not arrive in lumps, and particles cannot cancel one another out. And any experiment in which we try to see how the same thing can do both will, says Bohr, have to assume one of the two aspects in such a way as to render the phenomena arising from the other aspect invisible. The example he gives is that if we wanted to track a photon on the way to understanding how it could contribute to an interference pattern, we would have to know that it had emerged from one or the other of the two openings or slits used to produce that pattern. But the only way we could be sure of that would be to close one slit. But that closing would in turn eliminate the interference pattern. The more general account of the limitation, said to be inescapable, of our capacity to provide a full mechanical explanation of light, and indeed of all atomic phenomena, he abbreviates in the remark that the means by which we measure the smallest phenomena are of the same magnitude as those phenomena themselves, and thus our efforts to measure will disturb and significantly alter the very things we seek to measure. The situation has been compared by others to one in which every time we tried to ascertain exactly where a given object was located at a given moment, we would have to take a photograph with a flash, but that the flash would be of such a strength as to knock the object a significant distance away from where it had been. Finding out just what that distance was would require another photograph, and so on. Bohr calls the two seemingly irreconcilable but equally indispensable aspects of light complementary, saying, quote, "They can never be brought into direct contradiction with each other, since their closer analysis in mechanical terms demands mutually exclusive experimental arrangements," end of quote. And says later, quote, "The notion of complementarity serves to symbolize the fundamental limitation met with in atomic physics of the objective existence of phenomena independent of the means of their observation." I propose as an opening question for the conversation the following. What does it mean that the very independent existence of atomic phenomena is said to be limited by the means of their observation? And how might that help us understand the phenomena of life?
I guess the first thing one has to be persuaded about in these matters, I'm not going to go to the life thing right away, but
Can you hear him?
the first thing one has to figure out is just talking about this whole arrangement of measurement and smallness. That is, most people think right away, well, I could get a better way to measure this. But it takes a long time before you, at first you think, well, it's just my inability to measure something really, really, really small. And, you know, if you go through enough of these arguments, then you have to take the notion of complementarity seriously. And that, for me, has always been the hardest thing. What does Bohr mean by complementarity? The two things, they coexist. They don't negate each other to go on to something else. That might be the way one would go in another discipline, which Bohr thinks science can shine light on, that is to say philosophy. But so I just wanted, I would say, do we have a notion of what he means by complementarity? By the way, since this conference is also about the teaching of science is a liberal arts, I'd like to say that Mr. Stickney did a beautiful job, because you might have heard something that you wouldn't have understood a single word, but instead he was talking about pebbles causing waves, and I've never seen the description of wave superposition or cancellation put in such a poetic and concrete way. And then if we didn't have enough of that, then we had, the cannonballs. So that's just for those of you who are visiting the college. That's kind of how we try to get at things. Let us say not with language which is so simple that it dumbs down things, but language that gets directly at what we're trying to talk about. And eventually we end up, with a mathematics that we struggle at to actually talk about those things. That will probably be the end of our conversation. That there'll be a level where mathematics trumps all of this, but then we won't give up on that either. So yeah, so I'll go back. What is this? I would just like to know from my panel members how they live with complementarity. Many people didn't like that thought.
Well, it seems to me there's a couple of different ways to view it. And I look at this statement that Bohr makes. What does it mean that the very independent existence of atomic phenomena is said to be limited by their means of observation? And it seems to me there's a strong interpretation of that and a weak interpretation. The weak interpretation is to say, well, there's something there that actually exists. But the way that it looks is going to be different depending on what kind of actions you take to observe it. That is, you can do the kind of thing that will make it look like a wave, two slits. Or you can do the kind of thing that makes it look like a particle. You make it hit something and see what it knocks, like a cannonball, and see what it knocks off. But the stronger form of complementarity is to say, which I think is often said nowadays, is these things do not actually exist at all until they are measured. And I don't know if Bohr is saying that, but it does, that's really paradoxical.
Yeah, I guess a question I have about this is to what extent this is a problem just for light, and to what extent it's a problem for explanation generally. I wonder if the notion of complementarity that shows itself in the ways that we've been talking about reveals anything about what our prior assumptions about what explanations should look like are or were. It seems to me they might. I was a little struck by this claim early in this Bohr paper that the very essence of scientific explanation is the analysis of more complex phenomena into simpler ones. I wonder if that's going to get us into trouble, assuming that that's the case. And the reason I say that is that it seems to me at least one plausible idea about what's wrong with bringing that sort of notion to bear on the phenomena of light is that one never sees the thing by itself. One only sees it in interaction. And so there's a complementarity is as much as to say there's a limit on simplicity. You can't just get the thing by itself. And it seems to me that is the way we think about scientific objectivity or observation or explanation often. We're going to stand apart from the thing, and our way of watching it is not going to interact with it in any way. In other words, it's going to show itself completely without interaction. I think that is more general than a problem for the phenomena of light.
Maybe complementarity is the simplest account. That is, it's simpler than contradiction, and it might be simpler than any kind of mechanistic account. Is that possible, that complementarity, even though it might be hard to swallow might actually be the simplest account that can be offered. Which, by the way, leaves the whole question of what's simple up in the air. And so for us to speak as if we know what is simple and what is complex is already to make assumptions about what we expect from an explanation.
I think it's a little hard to accept an account as simple if it's not really intelligible. And Bohr says a little bit later in the paper, I think we all agree with Newton that the ultimate basis of science is the expectation that nature will exhibit the same effects under the same conditions. Okay, so that, I take it, he's substituting effects, maybe events, for things, for beings, the existence of which and the nature of which we could know. But still, there's an expectation of regularity. And that means there's got to be something there. So we can't, I don't think we can be satisfied with a version of complementarity that says, well, from a certain point of view, it's this. And from a certain point of view, light is a particle, a quanta. And from a certain point of view, it's a wave. And it could be something else from another point of view. It could be anything, right? It seems to me there's a limit beyond which we can't go in renouncing the efforts to get to achieve intelligibility. And I'm not sure exactly where that limit is. I'm not sure exactly what's required for intelligibility, but it seems to me that's something that we have to think about.
Right. I was wondering if it's our concepts that come into question because of the seeming lack of unintelligibility, whether wave and particle as concepts, because he insists on the analysis of our conceptual tools, not just of nature. And it seems that in that case, in some sense, I don't think wave and particle are being dispelled as concepts, but I was wondering if their application, whether the lack of intelligibility arises from the concepts that we use to understand whatever's there.
And you're thinking that perhaps there could be more adequate concepts. Is that the direct?
Yeah, that somehow physics is about analyzing concepts, which is not an obvious idea.
When Mr. Stickney gave his example of the water waves, we can see those. And I guess I wonder, do we see light waves? Do we see light particles? This is apropos, this is in keeping with the question of the concept. So we begin with a concept like waves in water because they exhibit certain kinds of effects that we then think light is exhibiting, namely interference. But we don't see waves of light. Tell me if anyone has. I want to know.
We see the interference. That's the great thing.
That it's interference.
And then we work backwards.
Right. And to call it interference is already to presuppose that light is undular, is moving in waves.
Maybe I'm being picky, but I don't even think we see interference. We see evidence which we interpret as...
We see bright, and then we see absence.
Yeah.
But we see an array of phenomena that are wave-like, right? We see
Sure.
refraction, we see reflection, we see lots of things that that match up point for point with the things that we do see.
Right.
Yeah. So it's hard in that case not to say, yeah, we understand this thing.
No, but just one more, and then I'll be quiet. We see things that are epicyclic-like, but that doesn't mean that that's what's going on.
This is going to sound completely off the wall, but I think it links in. and that is we had an all-college seminar on Wednesday, and we discussed a poem. We discussed Keats' Ode to a Nightingale, and it occurred to us that the Nightingale's song is really not something that is related to any particular individual nightingale. It's a song. The song that you hear a nightingale sing today is going to be the same as the song that some other nightingale sang in Keats's day. And so in connection with what Ms. Dougherty and Mr. Verdi are saying, it seems as if you don't necessarily need to have an single underlying individual reality behind a certain phenomenon. We have a certain thing that behaves the same, and you don't really. You need to have some kind of something there, but you don't need to say this is the song of this particular thing.
Excuse me. I wonder about Mr. Bleichmar's question about conceptual analysis in physics. I'm sorry about my voice. In thinking about what's going on here with the notions of wave and particle, it seems like the problem is that the concepts are extending, and I wonder about the source of the extension of the concepts. So it looks like waves are things like water waves, basically, and then they become things like light waves. You try to push it down. Particles are things like rocks, and you try to push it down to things like electrons, and then it breaks down at that point. So in trying to understand that breakdown or the inadequacy of those concepts, I wonder if it's analysis that one does to the concept, or because that seems to imply that it's something inside the concept of a wave that's not adequate, or if it's something about the extension of the concept. And I wonder what's driving the extension of the concept, if that's the concept itself or an application of the concept, or one should think about that.
It seems, I mean, this is just a clarification question, but it seems to me like the question is something like, are these terms in conflict because we've imported meaning to them, or are the ideas in conflict because there's something fundamentally at odds between continuity and discreteness, or fundamentally at odds between interference and individuality? So I guess, I mean, it seems to me there's still, like I said, it's really more a question of clarification, how we're taking these terms along the lines of what you said, Mr. Lasell. Where does the tension arise?
I think it's always a danger to attribute to what we can't see characteristics of what we can see. And I think that's part of what catches me too, about complementarity, is we don't see that in ordinary experience, but that's not a reason for us to attribute the very qualities that bring it about to what we can't see. And we can't see light in some sense. We can't see these characteristics at all. So I think that's a danger that it cuts across the board. Maybe not so much with the concepts, but with the fact that we may be too eager to give to what we can't experience properties of those things that we do experience. I don't know what else we can do, though, frankly.
Well, isn't this where the adequacy of an account comes in? Right? He in the passage that Mr. Stickney started with, Bohr talks about having an adequate account, and it seems to me that the word adequate suggests or implies that it's adequate for our purposes for the time being, maybe. It sort of brings together phenomena that we have observed in some kind of an account, but that's very far from saying we know what the thing is that we're investigating. The problem is, it seems to me, whether we really have good reason for abandoning ever to understand what really is there, because it seems to me we have to reflect upon that at the same time that we have to continue to revise the account to make sense, or to incorporate or include a new range of phenomena, right? And it's kind of hard to do both at the same time. It seems to me physicists do the latter for the most part. I think here we ask the former question, whether we have good reason for saying there is no complete account, and whether we can say that definitively, as Bohr says, as Heisenberg says, as some of, or whether we really ought to be thinking in a different way in order to come up with not merely an adequate but a true account. Is that, have we given that up?
I thought there was a question you raised earlier about the true account, whether or not the true account has to do with something as it is, independently or objectively. Yeah. And there are sprinkled throughout the essay enough hints, but not enough to go farther, so I'm just going to throw this out there and then duck. He begins on the first page by saying, light is our principal tool of observation, so that our relation to what we are inquiring about is mediated already by the subject of our inquiry. And so I think the questions of the relation of the observer, not in a collapsed waveform quantum mechanics sense, but of the observer as interwoven with the world we're investigating or able to stand apart from it, are sort of woven throughout the paper. So the question whether, one side of complementarity I could see here would be when he speaks of purpose as being the biological side, the biological parallel to quanta, that our own purpose plays a role in the investigations we do.
Yeah.
And so has a complementary relation to the objective, atomistic fact that lives somewhere else.
All I was going to underline, much less interestingly or well said than what Mr. Poppele and Ms. Dougherty have said, is a kind of claim that I think, I don't know, that set off some alarm bells for me was the claim, and I don't want to bring life in here too much, but just sort of along the lines, here he says sorry, this is on 10, right in the middle, the very definitions of the words life, the words life and mechanics are ultimately a matter of convenience.
Yeah.
Wow, he's willing to throw them overboard, it seems to me. In other words, our purposes in understanding things are going to dictate whether we stay with these words, whether we, that seems very different from the sort of question Mr. Lasell was posing about whether we should be looking into the concepts themselves and see if there's some sort of inherent tension within them or some sort of just lack of applicability to phenomena. And I think this question of what it is we're trying to do in explaining is inescapable. We can't get around it. So how will we know when we've got an explanation? Well, we won't know if we don't know what it is that we're trying to do in explaining. And it seems that a lot of what we do is to, as Mr. Verdi was saying, is to make sort of likenesses and say, yeah, I kind of get it. It's kind of like a pebble in a pond. And that only goes so far.
It's not.
Well, but it's also not.
Mr. Lasell's remark and Mr. Donahue's moved me to think that part of what we're doing is trying to find not this or that nightingale, but the nightingale that Keats says, the song of whom was heard by emperor and clown many centuries ago, that we drive our explanatory hypotheses to their limits because part of what we want from an explanation really seems to be that it will explain everything. That we want there to be such a thing as everything, and we want that everything to hold together, to be in some way discernible as entirely interrelated. And it's a hard moment to say, well, suppose we throw that one out.
But we don't, this may be slightly off topic, but we don't make the same demands of language we don't demand that every word have one precise meaning. We tolerate ambiguity, we use it, it illuminates. Why do we feel, and I'm just asking this as a question, why do we feel we can't tolerate ambiguity in an account of nature? I mean, I think what we're saying is we don't want to do that, but we do tolerate it and make good use of it in language, in poetry. Why not in a scientific account?
So complementarity, at least in the scientific realm, comes into being not with light, but with the notions of where something is and how much motion or how fast it's going. And so that's something one can grasp, it seems to me, a little more concretely, although it's a shocker that I can't know both where something is and how fast it's going at the same time, or that I have to, like, if I can cash in my knowledge of where it is. In other words, I can go back and forth. And so that comes from looking at very, very small things, and in the end, at least the first shot at it, representing those small things as waves, but very complicated waves called group waves, which are themselves an infinity of waves traveling at different speeds. And so, and I have to tell you that, I've learned enough, although I'm just a student of the liberal arts, to know that that itself is simply thought of as a picture or a representation by the next level of people starting in 1930, right after Bohr. So basically, where am I and how fast am I going? That can't be known with absolute precision and accuracy, both those things that we trade off one for the other. And so Bohr comes up with the notion of, well, these are the position and, in this case, momentum, or how mass times how fast you're going, are complementary notions. And I guess it's Heisenberg who says, this means that our ordinary concepts are going to have to change. Now, we at the college, remember, because we read Aristotle, and we realized that there might be other ways of talking about place and other things, ways to talk about motion. Those scientists don't immediately get into that, and insofar as we're studying these sciences, we often don't take that detour back to them. But I guess my long-winded point here is that by the time we get to this paper, Bohr has thought through his way of seeing these complementary notions in the realm of material with respect to light. And as you see, he goes even further here. He's getting into biological things, and so it's kind of fascinating. I'm both excited when he extends what seems to be perfectly legitimate in the realm of where something is and how fast it's going. One wonders, it makes it harder for me, at least, to know, because it's no longer something that we're measuring per se. For example, when he says that a wave and a particle are complementary, that seems to be a different kind of notion. It's not the more I think of something's a wave, the less it's a particle. So on the one hand, it looks like he's getting at a bigger notion and maybe more worth our conversation. But it's harder for me. Especially when the title is Light and Life.
Yeah.
So that's the end game.
Yeah, when I first started teaching at the college in freshman lab, we used a manual called Theory of Measurement until one of my colleagues in a faculty meeting said, there is no theory of measurement. And I wonder if when we talk about measurement here, if maybe we're thinking of it in only one way, and maybe that's the problem. Maybe we're going back. There is a theory of measurement. All measurement is somehow the same kind of thing. And maybe the measurement of things that are small, or the measurement of things that are very heavy or very far away, is not the same kind, it's not the same concept as the measurement of the length of the table. I don't know. I'm just throwing that out because it struck me as a new tutor that all it took was one person in the faculty meeting to raise the question, just to say there is no such thing as theory of measurement, and I thought that was right.
We were talking a moment ago, or I think John was asking, Mr. Verdi was asking about literature versus science and thinking about the way we accept ambiguity in literature in a way that scientists don't seem to want to. They want a sort of unified explanation. I wondered if we could think about the analogies, the kind of analogies that Mr. Burke is talking about here, that he indulges in so much in this paper, and think about how a scientist might want to think about analogy. When a scientist gives us an analogy, is that a prelude to a kind of unified theory, or is there some sort of restraint that's holding him back from that, and what that restraint might be in this case?
One of the, I guess we are getting into the question of life a little bit, since that's the end analogy. And one of the things that, not knowing anything about complementarity, I was suspicious of was that it's always two things. That it's either particle or wave. It's either electromagnetic wave or quantum of action. It's, what's the third? It's either stationary state, so it's always either or. And I was thinking of situations where, why aren't there 4 complementary explanations or 10 complementary explanations? And that's where life, that's when I don't even know what the problems of life are that would be equivalent to particle wave. It seems that diversity and multiplicity is sort of intrinsic to it in a way that doesn't seem like it'll lend itself to complementarity.
Yeah, I wondered about the same thing, and I wondered if he were gesturing towards when he talks about the fact that in the same way that, sort of like Mr. Stickney's example of the photographic apparatus that has a light bulb so powerful it knocks the thing away that it's trying to fix the position of. In a similar way, when you try to get down to the atomic level of the activities of the various parts of the liver, you can't watch them all while they're doing their business without getting in the way of their business. Right? So there's some way in which the activity of the living thing in its living is inextricable from the material exchanges that it has with the history and the particularities of its context might be. So in a way, like, we can't isolate the living thing, and we can't control it. I don't know, there's no control group except dead things, right? So I thought there was a likeness there. So yeah, you don't get the same kind of straightforward contradiction between two different explanations that are incompatible in some way, but you get an inability to pull the thing out of its context.
Does that imply a kind of duality, though? A duality of observer and observed as a sort of fundamental complementarity? And then I don't know if we can read all these others as reflections of that. It's a little harder to see wave-particle duality as one side being the observer and one side being the observed. Maybe there we'd expect something else.
I wondered if metabolism were the main thing, right? There's always exchange. Remember, he says, you know, we go in there, we don't know what's part of the being and what's part of the, yeah.
The inorganic, but absolutely necessary matrix of the being, yeah.
But that seems like that raises another player, right? I mean, I was thinking of the exchange as being, if we have the atomic or molecular level, which we can investigate only by destroying mechanism. We have the mechanistic level, which even when we look at it seems to take us away from, I don't know how it relates to purpose. I mean, how far we need to go from mechanism to purpose. Maybe those two are tightly related, maybe they're separated. Since he speaks of psychology, that might suggest a higher level. But then we also have that matter itself is in flux. We have the exchange of material. So I've been wrestling with a way of trying to put those into two parts. And we also have the question of the observation per se, I mean, that which comes in especially, as he says, with psychology, but clearly in the liver as well. You can only look so carefully before what you're looking at are parts of something that was a liver. It's not livering anymore. So I wasn't having as easy a time, as Mr. Bleichmar was asking, making this two-sided complementarity. On the other hand, he clearly says purpose is, is analogous to quanta, as though it were the missing piece complementary to the other piece. So I guess I'm not clear on how he sees that other piece.
Yeah, I wonder if we shouldn't also include here some discussion of the kinds of questions that are asked. That is, I mean, it makes good sense to be aware of the ambiguity of the living organism, that it is both simply a collection or a locus, maybe, of events, and a fluid collection of particles in motion. And so we can look for a mechanical explanation, but we also find ourselves at certain points having to think of it as an organism, as somehow some kind of whole, even if it's not fixed. But it seems to me the questions that are asked a lot of them come from medical needs, right? So that it seems to me there's a kind of grounding, there's a place one starts with those questions. And it seems to me one can tolerate the ambiguity because it's kept within bounds to a certain extent by the attempt to focus one's inquiries for an end that we're all aware of. Now, of course, in the pursuit of medical advances, people sort of get distracted and just get interested in what they're doing, and who knows where that goes. But and just want to know more of the same kind of thing, even if it isn't very useful. But still, there's a place that you come back to, which is, I think, precisely what we have to renounce an explanation of, according to Bohr's account. We have to renounce an explanation of our conscious activity, just as we're renouncing full accounts of what is in the material world when we come up with complementary accounts of particles and waves, or energy packets and energy waves.
Will we be unsatisfied in some account of living things, of life, let's say, if we can't reduce sort of the continuous nature of ecology, of the ecosystem, if we can't reduce that to some kind of quantum of life, like a cell? Will we be disappointed if we can't do that? If we can't in the end say, yes, I understand why these trees are clustered this way, and it's because these cells are acting this way, or if the quantum of life is even smaller, I'm just taking the cell as a beginning. It seems to me that when we think of living things, we have a similar kind of complementarity. We can think of the whole thing, which is a continuity of sorts, or we can think of those little parts of which everything is made. Now, I don't know. Maybe we won't be happy until we explain everything in terms of the quantum of life. Is there a quantum of life?
It can't be, it seems to me, a complete explanation, and maybe this is still similar to the quantum theory, because it seems that a living system, the activity of a living system depends deeply on its history, on what it exists as a consequence of what's come before. And so no unit of it is descriptive of the whole without an understanding of history. Now, that may be something like what happens in the quantum mechanical experiments, where we say it's the history of the photon, particle or wave, that would tell you where or why it did what it did. But we're prohibited from seeing that. Maybe there's a similar problem in some ways with that analytic approach to life. We're prohibited from understanding the things that brought it to be what it is.
Could you expand on that a little? Could you just say a little more about that? I'm not understanding why it is that we're prohibited from from following what it is that
Well,
brought?
I thought, I mean, in the quantum mechanical side, we can't say which slit a photon goes through without closing one or the other, in which case we don't have the interference pattern that raised the question. In the biological side, it seems to me what we're given is a moment in time that has certain relations of being, but those are all contingent on the relations of being that were immediately prior to it, and so on. And so there's a way in which the immediate relations are not explanatory, the immediate account of each cell isn't explanatory of the activity of the cell, but that the history, yesterday was cloudy, it has rained, these cells were producing something like this and other cells respond. An evolutionary account, to go back in even broader terms, what brought the manifold richness of life to be in these forms here, being the kind of history that seems to me outside of our grasp in terms of a complete account of what we see.
Yeah, that's interesting, because, hi, sir, go ahead, no, please.
No, please go
No,
ahead.
I know you're gonna
Get him the microphone, though.
Okay. Just to come back to this history idea, I just wanted to rejoin something that Ms. Dougherty said earlier about the sort of medical background to biological research. It seems to me it's not just a sequence of events, right? If we're going to call something the living being's history significant, we're going to say that the thing that is in front of us is a historical being. In a way, it's in terms of its project of staying alive, right? Nourishing itself and interacting with its environment and being itself. I guess I wonder then if there's some way in which the kinds of questions that we ask, and this is going a little bit backwards, if the kinds of questions we're asking are different because in a way we're joining our interest with the interest of the thing, right? Like we're interested in the liver, I mean, unless we're, I don't know, studying poison or something like that, we're, in order to use it, we're studying the liver to make it healthy, right? That's what we want. We want to help it be the thing that it is. I wonder if any such thing can be said in physics. Are we helping electrons? Are we trapping them? Are we torturing them? I don't know.
It seems to me, in light of that, it's worth pointing to the Bohr's discussion of the eye.
Yes.
Now, it seems to me, first of all, you have to recognize the eye as an organ. Now, it's connected to a whole lot of other things, but when Mr. Poppele was talking about the history, I was wondering, well, the history of what? Because how do you know where to stop? Everything's related to everything, and it becomes impossible to even ask a coherent question unless you can sort of set some kind of boundaries, whereas the eye, I think, comes to our notice as something worth investigating. And in the investigation, Bohr remarks on something I think is really striking. He says, since the absorption of a single light quantum by each of these retinal partitions in the eye is sufficient for a sight impression, the sensitiveness of the eye may be said to have reached the limit set by the atomic character of the light processes. So, okay, we use microscopes and telescopes in order to see things we can't see with our eyes, but they're not better suited to their goal, to their use, than the eye is. The eye has sort of maximized the ability to focus on something given the characteristics of light. And it seems to me, something is, that remark, that the awareness of that fact, I guess, is only possible if one asks the sort of question that comes out of an awareness of the integrity of the organ, which of course is not absolute. There's all kinds of ambiguity in the sense that it's a part as well as a whole. But
A moment ago, Mr. Recco was asking about the physicist as well, and it seems like it's sort of identifying with the purpose, or something like identifying with the purpose of the electron would be the analogous thing. It seems there has to be, I guess I want to say the physicist does do that in a certain sense. I imagine what happens when one does an experiment. One sort of roots for the thing you're experimenting on to behave in the way that's natural for it.
Please do.
Yeah, and so I think that maybe it's sort of you're aware of the integrity of the object, and you're saying, like, let me see the whole behavior of the object. Yeah, you're getting the obstacles out of the way. All this stuff is interfering with your electron behaving like a normal electron. And so, yeah.
But normal according to your model, right?
Well, yeah, but the intention is that it's normal simply. I mean, you're not saying to yourself, I want it to fit my model so much as I want to see what that thing's doing, and I think this is what it's doing. This is my guess, so let me see if it'll show itself somehow.
It just seems to me we're on shakier ground in trying to determine what's normal for the organismic.
Yeah, I guess, yeah, we're definitely on shakier.
Non-living.
We're definitely on shakier ground, but it seems to me also, I think that's very much part of the intention of someone doing a scientific experiment.
I'm
So,
sure that's
yeah,
right,
I-
yeah.
It seemed that he despaired of it at one point, where he says that the degree of freedom we have to give the organism is just enough for it to conceal its ultimate secret from us. That seemed, and it didn't seem, I don't know if to think that he's depressed there, or that he's, that it's whimsical and generous or something, but there's this sense of life is gonna slip out through the small chink that we must give it if we are to understand it. It just seemed a very strange moment in the...
And maybe it's only that such astonishing progress was made so rapidly for a while with non-living nature that, I mean, that it's kind of touching when Bohr says that when you see an interference pattern, you don't experience any doubt that light behaves in a wave-like manner. And when you see the number of phenomena that parallel the behavior of physical waves in water or things like that, and the giant shadow of Newton falls over this paper too. He says, well, what lets you know how well quantum mechanics has worked is that we can compare its success with Newton's success in explaining the behavior of all the heavenly bodies. And so it looked for a long time anyway as if making things as simple as possible and building complexity from those very simple things, we could get a structure that paralleled the universe, that we could have perfect clarity in the microcosm leading to an adequate, a convincing account of the whole of things, but that really what you've said about the living thing turns out to be true about the non-living thing as well, that if you really pursue it to its tiniest layer, it always has a back door. You don't get to the perfectly understand the atom of knowledge, as it were, the perfectly self-evident, undeniable thing, out of which, according to perfectly understandable rules, you could build everything.
Well, the rapidity of the success of quantum physics seems to go in both directions. It both raises your hopes, but then that it happens so fast means you suspect that something might slip out from under you the very next moment, I suppose.
And that it is itself telling you, well, finally we're relying on probabilities. There's a certain way in which we can't tell you why the stationary state ceases to be stationary, or why it can even remain stationary, right? How come it doesn't use itself up moving that electron?
I guess I'm not persuaded that that complementarity isn't a clear account. It is clear. We know what the photon is going to do if we do certain things to the apparatus that measures it. We don't like those. We don't like what it does, but we know what it's going to do. We know what it's going to do to a high degree of precision. That's very clear, and maybe we need to put our likes and dislikes aside. I don't know. I don't know what I don't know what would constitute clarity better than being able to say, if I do this, this is what's going to happen. And that's,
Well, there's the statistical character is a problem, right? You rotate the polarization apparatus this, and there's a 50% chance this will
That's
happen.
clear.
50%.
that's clear. I mean it's clear. No, I'm serious. I mean it's clear in that it's not 40%. In other words, we know
Definite answer.
it's a definite answer. And what more does one want except a definite answer?
A sure thing.
Newton wants more. Newton wants more, and Bohr says he agrees with Newton that the ultimate basis of science is the expectation that nature will exhibit the same effects under the same conditions. And the statistical character of quantum mechanics rubs your nose in that. And yeah, maybe you do have to leave what you want behind.
No, but it does give you the same. First of all, same is a loaded word, right? So if I turn the polarizing filter these many degrees, I'll get the same probability function as I got yesterday when I did this. There is a sameness. If we don't like probability, then we should just say it.
I don't like probability.
I don't like probability.
I like probability, but I'm not convinced. Because same there says we get the same probability function. Well, no, we're always going to get an aggregate of data that approximates our probability function. So it's to raise the question of same. I thought what Mr. Lasell was suggesting, well, if we put in a polarizing filter and we look at one photon, that's going to do something different than another photon. And we reason that the extension of this process produces a statistical, or a distribution that can be described probabilistically. It'll never be exactly it. Right? So maybe it's just pushing more, as you'd said, on the word same. At what point are the data the same? And I said, I've never gotten the same data.
It is now incumbent upon me to, alas, point out that there's no natural point at which interesting conversations terminate of themselves. And I think probably it's about the right time for us to adjourn for tea and cookies and reconvene with those who wish to join us for further conversation. So thank you all very much.